Hey folks, welcome to another episode of CockroachDB Bytes. I'm your host John St. John, and today I'm going to talk to you about the very, very exciting topic of node authentication. So let's hop right into it. So this question came up just really recently with some folks I was talking to about what the requirements are for the certificates that enable nodes to authenticate with each other and communicate with each other over TLS. So that's what I'm going to talk about here and learn my lesson. I'm going to hide my video so I don't block the slides. But so this really mostly applies to, actually I'll share myself again. This mostly applies to when self-hosted CockroachDB, as most of you folks know. There's also the managed service and Cockroach Cloud, dedicated. But if you're spinning up your own secure cluster locally, or maybe in a cloud provider or in an on-prem environment, you need to set up the security certificates that are used so that the nodes can communicate with each other. So there's a couple different types of TLS certificates that are used. There's ones for intranode communication, and then there's also ones for that you can use if you want to authenticate as a user into the cluster, as like a SQL user for, say, like a SQL client. We're not going to talk about the SQL client certificates. We're going to be talking about just the node-to-node communication. And what does that mean? Well, the nodes communicate with each other over gRPC on a secure connection. Unless you were to start up the cluster just for just playing around with and testing in insecure mode, which you can do. It's not recommended for any production use case, but for a standard production use case, you would create the cluster in secure mode, and then you would need to be able to secure those channels of communication between nodes. So each node must have a node certificate. And typically that same certificate is used when the node acts as a client or a server. So think about it in a typical TLS setup. You have a client, and that might be, think about me in my web browser that's connecting into maybe a website over in my browser. And that website's going to have a server certificate, or it's going to act as a server, and I'm going to act as a client. Well, it's similar with node authentication. If, let's say, node 1 in the picture below is reaching out to node 2, node 1 is going to be the client in that scenario. It's initiating the request, and node 2 is going to be the server. But because there's bidirectional communication in a cluster, node 2 can also reach out to node 1, and node 2 might act as the client in that situation, and node 1 would act as a server. So there's a way to make it so that you can use two separate certificates, but unless there's some special certificate restrictions that you have within your organization, it's very common just to generate a single certificate that can then be used for both roles. So there's a couple requirements when you create a node certificate, and that is the host name or address, the IP address or DNS name, used to reach a node either directly or through a load balancer must be listed in either the common name property or the subject alternative name fields of the certificates. So now certificates are, I think, unless you're really familiar with certificates, they're a little bit confusing, like what's the common name, what's the subject alternative name field. Those, I won't go into a lot of detail, but they're just properties on the certificate, and when you create a certificate, you need to specify them. And then CockroachDB must be configured to trust the certificate authority that signed the certificate. And we do that by taking the certificate authority certificate and placing it on the node so that it can use that to verify the authenticity of incoming requests and the certificates that they're signed with. So let's go on to the next page. So in a typical, or maybe a standard cluster setup, you'll have a few different files that exist on each node, and they need to be on every node. You have the ca.crt, which is a certificate authority certificate, and then you have two node certificate files. You have the certificate, and then you also have the private key, which is the key for the node certificate. And as I mentioned, the node certificate functions as both a client and a server. So what do these look like? There's a couple different options for how you can generate these, and there's a built-in certificate utility in Cockroach that you can run from the command line. And remove myself. That's just Cockroach cert, and it has a subcommand called create CA. So if you're starting from scratch and you don't even have a CA that's generating the certificates, you can actually just create a certificate authority just using these commands. And then as a practical example, you maybe if you're creating these locally, you can make a certs directory, and what we just mark as a safe directory, which is where we might keep private key material. And then we can use that create CA, and then that'll generate the CA certificate and the private key that goes into the safe directory. So if you're not familiar with certificate authorities, the certificate authority certificate, the .crt file, can be shared around, but the key file, which is the private key, is then used to sign new certificates and generate new certificates. So that needs to be kept somewhere safe or private, and that wouldn't leave like a machine or an environment where that's secure and protected. The private key is never synchronized to the nodes. And again, this step is not necessary when using an existing certificate authority. So if we take a look at that CA certificate that we just generated, and you can use OpenSSL to inspect it, we can see that I highlighted a couple key characteristics of it. So if you're using that Cockroach create create CA command, the common name, which is CN, will be Cockroach CA. And then the key usage is for digital signature, non-repudiation, key encipherment, and certificate signing. So these are the attributes that you would expect to find in a certificate authority certificate. Now, to actually generate the node certificates, what we need to do is include all the host names and IP addresses that are used to reach the node. And they can be listed in the create node, the certificate create node command. That might include a load balancer if the node is accessed through a load balancer. And that ensures that the identity of the server can be identified by the client that's connecting. So this command is pretty simple. And again, there are examples of how to do this using OpenSSL without using the Cockroach cert create node capability. And as a practical example, for the first node, we might have a few different names for it. We might have an IP of a load balancer. And we run that command, and it generates those two files. So both the node certificate and the key have to be synchronized to the node. And after that's done, then you can move on to node number 2. So we would follow the same process for all the nodes in the cluster. Now, if we wanted to look at that node certificate, we could see that Cockroach uses a special common name for node-to-node communication. And that's just a convention. And so that common name is always going to be node for the node certificates. So we see that common name here. And if you're generating the certificate with a different method like OpenSSL, you would need to specify the common name of node. And then we can see in this extended key usage section that this certificate is good for acting as a web server, or just a server essentially, or a client, web client, or a client. So that's what I was saying earlier, is these are dual purpose certificates. They can be used for both parts of that bidirectional node communication. And then we see that those host names and IP addresses that we passed onto the certificate are going to be included in the subject alternative names for the certificate. I think that's it. Yeah, so that is the overall overview. And so this would be a really standard way of initializing and setting up your cluster. Again, if you are interested in not worrying about a lot of these details, then you can also use Cockroach Dedicated or Cockroach Cloud or Managed Service. In that case, this is all done for you. But if you're setting up your own cluster, maybe on an on-prem environment or in a cloud environment, then you'll have to go through this process to create these certificates, put them on your nodes, and then when you start your nodes, they'll use those certificates to join into the cluster and communicate with each other. Yeah. So hope you found this interesting, and this is really just to give you a little bit of a look at the intranode communication and how it's secured in CockroachDB.